Hello again, everyone. I am Mahmoud Ramdane on Afterwork Workflow, and first of all, I would like to thank you all for your commitment to our channel, and thank you for joining and subscribing and adding up to the Discord channel. I know lately I've been somehow really busy, but I found some time today, inspired an idea, since I'm working on a really interesting project. This project I'm working on is at my office, and we are making a facade. So the idea is to come up with a perforated paneling system using metal sheets, and they are perforated actually using CNC. And as you can see, my Pinterest research is all about how to dress up paneling on surfaces and how to create these types of openings. And so you can see there is a lot of ways to do so. Let's take this image, for example. This one is really nice since we can see the technical aspects of it. So as you can see, we have an offset, which means there would always be a little threshold of the cuts, so it allows easier manufacturing in the warehouse. Also, as you can see, we have a gradient. This gradient goes from center to top. So the more we approach the center and the more we go up or down, the scale, let's call it the scale for now, the scale of the openings is reducing. So what is this effect? This effect is called an attractor point. And today we are gonna make a panel system using attractors. So let me look for attractor points in Grasshopper. A lot of threads on the forum were made for this one specifically. And as you can see, here we can see an image of a perforation system, I guess. So what is an attractor point? It's this one here, this one here, this one here, and this one. Attractor points are points in space that have capes, that have superpowers, right? And their superpower is to actually command all the other points. By that I mean the central points of each circle, right? To command the circles or the points, for now, to change their behavior. For this example, these circles are changing behavior, and the parameter that changes is actually their scale. So we all know that a scale changes from the center, and by changing the scale, the radius goes down, and we get this gradient effect that goes until it reaches the... Also, we notice something, that the smaller ones are really small and the bigger ones are really big. So they almost touch each other. I mean, they do touch each other, which means that the scale here is 100%. And once we start going towards the attractor point, the scale gets lower and lower. So I guess probably here, if we're at 100% here, probably here it's 6%, let's say. So this is basically what an attractor point does. And in Grasshopper, it's not that very fluid. You cannot just put a point and tell it to become an attractor. You need to understand the logic behind these points. So for that, we're gonna make a small exercise. So in this small exercise, I am going to start by drawing one panel and deciding to perforate one single panel using circles and one attractor point. For that, I'm gonna draw a rectangle. Let's say it's 2 meters per 3.2 meters. Here we go. We have our rectangle. It's on the X and Y plane, right? Let's move it somehow to the center. Great. I clicked on F7 to remove the background grid. And I'm going to start by creating a curve. So I'm gonna also launch my bifocals. This one is a plugin. It helps you to see the names of the components. So once I have the curve, I can set one curve. So guys, if you're already here and you don't know what I'm doing right now in Grasshopper, please get back to the older videos where I created a very streamlined introduction to Grasshopper using one exercise as a method, basically. Great. So now that the curve is referenced, I would want to create points inside this curve. So before creating points, I'm going to turn it into a surface. So for that, I'm going to use boundary surface. Basically, it creates a surface from a boundary. And then I'm going to use a command called divide surface. These are my components. So as you can see in divide surface, we have a surface that is divided into many points. And it asks you for a U count and a V count. What is that? Let's check that out. So I turn my curve into a surface. Once it is a surface, I plug the surface into surface. And then as you can see, I have many points that are exactly on the top of my surface. Right? So now I can start making circles. Circle, choose the radius 0.22, for example, and then I start changing the radius. So I have many problems until now. First of all, I have the circles at the edge. That's the first problem. And the second, I mean, we need to keep an offset, right? We need to keep the empty space. And also the second problem is that I cannot control, however, the distance between the points. I want it to be somehow normalized. So if I'm going to production at the warehouse, I would exactly know what are the lengths of my points. So I'm going to use Alt and move this a little bit, and we're going to add a little script in here. So what I would want to do is, first of all, use a component called dimensions. So dimensions, you give it a surface, and then it gives you the lengths of these surfaces. Dimensions, basically. And as you can see, we have a U dimension and a V dimension. So to be very simple, let me explain it this way. I take a screenshot and put it in here. So basically the V is the vertical and the U is the horizontal. So you should know that each surface has a U and V direction. And this U and V direction is what decides the level of complexity of any surface. So for example, if you have a curved surface, you would have many lines that have many directions and so on. Let us not get into that for now. So as you can see here, I have my U and V dimensions. What I would want to do is to multiply this dimension. This one is the U dimension. I would multiply it by 20. So I would add more points in the U dimension. So 2 multiplied by 20, it's 40. So once I plug it, it gives me more range of movement, basically. So I would do the same for the V direction. I would keep the same number slider for both of them, and then delete these two. I don't need them anymore. And I would just plug this one in the V count. Great. Now we have many points that we can change using this number slider here. Amazing. So the next step is to define what is the best radius, or more specifically, what is the radius of the 100% scale. I want the radius that would make my circles touch. So how would I know that? I guess I have a plan. So the first thing I need to do is to actually calculate this distance here. Once I start calculating this distance, I can divide it by 2. And actually this distance divided by 2 is the radius of my new 2 adjacent circles. Let's do that. So for that, we're gonna have to choose 2 points. How can we choose 2 points? I'm gonna use list item. So if you get back to the other videos, you would understand that each component transforms data in a way. So for example, this one here gives me a lot of points. I always use a panel to see what's happening inside my components. And this one here gives me many points. So basically these are coordinates X, Y, and Z. And so the good thing to do right now is to flatten them. What do I mean by flatten? As you can see, I have many branches, what we call branches. So these are branches which are like big groups that contain many sub elements. When I use flatten tree, what it does is that it deletes all the branches and puts all the points in one big group called group 0. More specifically and technically, branch 0. And so now that I have my branch, I can start choosing from this big container of points the first element, which I will call element 0.1. It's a 0.0 with index number 0. The index is actually this name here. So if I put the index is actually this hierarchical aspect of the points. So the index number 0, let us find it. Normally if I tap on it, it should turn green. Yes, it's exactly this one. So if I don't want to find it visually, I can click on my mouse scroll and then choose to zoom on the point. So this is basically point number 0, which is this one. And then I'm gonna copy this and choose point number 1. Point number 0 and point number 1, these are the exact 2 points that I need. Why? Because I would calculate the distance between them using a small component called distance. I need to know the distance, which is 0.05, that I would divide using division by 2. Just gonna type 2 in a panel, it would always work. And then now I have my radius. And this radius here is going to be plugged into this one. Great. So as you can see, now I have a fairly good 100% circle. Also, what I would like to do is that since I flattened here, I'm gonna use the same flattened tree to create my circles. I don't need many branches, I don't need many groups of points, because divide surface actually just puts the points based on a grid system, etc. Anyways, let's get into that later. So I put it down here, and now that we flattened, you can also see that there is a difference between these wires here and these wires here. That these ones here mean that we have multiple branches, and these 2 lines here that we have one data tree, right, with many objects, basically more than 2. And so now that I have created my circles, I can start playing around with the multiplications here, either to make them smaller or add more in the U and V direction. Just make sure they are not really touching. Great. So for now, I have my points. I'm gonna deactivate them. Control Q to deactivate. And I have my circles. And here I have my component that has all the curves that are the circles. Great. what is my next step? So I guess that in order to have a good CNC milled perforation, we need to have some sort of threshold, right? We need to leave at least some millimeters so that the cutter would find place to move around. So what I would want to do is that after I did my division to get the radius, so basically here I have a data, which can just replace it and rename it. I will rename it radius. So before I get the radius, probably I need to subtract. I will subtract a value. My value would be 0.001. And let's see how that goes. Nice. Now I have my threshold. Probably I would also make my circles bigger. So because I guess those are not really realistic values. Something like this is fair enough, I guess. Great. So now that we created the circles, this is actually our, wait, what's happening here? Yeah, so this is actually our first part. Creating the surface, dividing the surface, flattening the points, so we have one branch, and then calculating the distance, dividing it by 2, and then subtracting the CNC threshold value or dimension or distance for now. And then we get the radius. Great. So now I can start using a point. I will just create a point, which will be my super point, which is my attractor point. So how does an attractor point work? An attractor point has a superpower. So basically his superpower, and let me do it figuratively here. Its superpower is that I'm just gonna set one point, right? So I would integrate it and then create a line. This way I would connect this point to all the other points, right? So his superpower is actually calculating the distances between this point and all the centroids of all the other circles. And as you can see, sometimes we have longer lines, sometimes we have smaller lines. So what we want to do is to make the value of the length of the line a radius, which means I need to transform these lengths into viable radiuses for these circles. I would want to transform this distance here and turn it into a small radius, and it would be also proportional. So the longer the line, the bigger the radius, and the smaller the line, I guess the smaller the radius. So how do we do that? We call it remapping. What is remapping? Let's check it out visually. Remapping is a procedure where we take some values. They should be numbers, as you can see. I have 0.1 in this icon, which means it should be like a number. And we have a target, a domain, a target domain. So what do we mean by value? What do we mean by a target? And also look at the icon. It looks like we have some sort of filter that is transforming data from one scale to another smaller scale. Okay, interesting. Maybe this would give us an idea. So I created this line only for understanding purposes. Now I'm gonna delete it. And actually what I would want to do, this would I would call the attractor point. What I would want to turn it into a text. What I would want to do is to calculate the distance the same way we did in here between my attractor point and all the other points. So this distance is actually the values that I would need to turn into radiuses. Okay, so I know now that my 100% radius, my biggest radius, is 0.045. So I know for sure that the biggest one should be this number. And the smaller ones, I need to start playing around using actually a target domain. So what is a domain? Let's construct one to see what a domain is. I'm gonna use construct domain. It starts from 0 to 1, I'm being told here. So basically a domain is the range of numbers, is all the numbers that are between 0 and 1. And guess what? I can change this 0 and I can change this 1 here. I can choose a domain start and I can choose a domain end. So basically, I'm transforming all these distances, sometimes very large and sometimes very small, into radiuses. So this one here is the combo. Basically, the target is my new domain, and my new domain starts with radius 0. Let's start with radius 0, okay? But the domain end should be the biggest radius, which is actually this value here. All right, so now that we have this done, I can see that I have an output which is called mapped. So basically what it did is that this component scaled down these distances accordingly to the previous lengths. So the 2 becomes 0.09, the 1.9 becomes 0.08, and so on. I guess we have 630 circles. That's too much, but let's do it for the sake of the exercise. Okay, so now that we get these values, I'm gonna use a data again component and call it new radiuses. So I have 630 new radiuses, and if we get back to this flattened tree, these are my points. I have 630 points. So the amount of values, radiuses, and points are matching. Great. So now I can integrate these new radiuses as my radiuses. See what happens? I'm gonna select all, Control A, preview off, and then only activate the circles. So as you can see, I have here my circles with the newest radius. And I guess also I might add some threshold so they would not clash, or just change the number of the points in this part here. Great. So now as you can see, I have created my first attractor points with superpowers. What it does, calculates the distances, turn them into radiuses, and then change that radius, basically. So we forgot something. As you can see, sometimes when I change the placement of the point, the circles still clash. Why is that? Because we forgot a very important part in our little combo here, which is called bounds. So in order that this big machine called remap numbers does the work and transforms the values into radiuses, we need to give it the source of our base distances. What do I mean by that? So these distances, I need to know what are their bounds, which means what is their domain. I give bounds these values, and if I grab a panel, they will tell me that these distances all those distances that are here are bound between a minimum and a maximum, which is 0.02 and 2.3. So the largest one is 2.3. So basically this should be our source. Great, let's do a recap. And also, yeah, I can change the domain start. I don't want my circles to be that small. So maybe I would do a 0.07. That's too much. 0.007. That would be legit. Fair enough. Yeah. I can see that the attractor points are doing their job. I'm getting the values, transforming them into a maximum radius, which is the domain end, and the minimum radius that I'm choosing here. Great. But is this radius is what we need, because I can see that they are not growing as I want them to. So probably, yeah, I need to reduce. I don't know why it did move. CNC cutting threshold. Great. And nice. So now I can start creating my panel. A panel is basically a surface, as you know, right? It is a surface with holes in it. So right now we only have curves. So now that we checked this first combo, we're gonna look at another combo that creates surfaces. So the first thing to do is to take this curve, just create another curve and move it until here. I'm gonna scale it a little bit from its center using the area component, and I'm gonna give it a factor of 1.0.2, for example, and I'm gonna have to check how large it is. I can either do a scaling, or if I want to be more precise, I can do an offset. For those who already use Rhino, they know what an offset is, and I can choose a distance, 0.22, for example. This, in my opinion, is better and consumes less time. So now the trick is to create a merge and to create a boundary surfaces. So here I have many curves, many circles, and they all are in a boundary. So what I can do is use merge so that boundary surfaces understand that the first curve is the bounding one, and all the other curves are the one that are inside. And then I would connect the result to my boundary surfaces. Look what happened. I have my surface, but I also have many other small surfaces which are the circles. I don't need that. I only need perforations. So what I would do is here, since I have this many branches, as you can see, branch 0 and branch 0, 0, I maybe can flatten. So I'll do that using, sorry, I did it the fast way. So basically the fast way to flatten is to click on the result and just click flatten. I'm gonna do it the hard way. It's always good to work this way when you're starting out, so you know the names and the wordings for each thing. So after I flatten the tree, after I have everything in one single branch, so as before we had two branches, one with 630 numbers, number of data, and the second one with only one number of data. So I plug this flattened tree into my edges, and now I have my boundary surface. If I change the placement of my point, the design will change, and I can now bake my newly created surface. Now let's make architecture. Maybe I can duplicate these edges. I'm gonna select them using Control Shift and then duplicate edge, the command. Then I'm gonna join them as they are still selected, and now they make me one closed curve, and I can use the gumball, the small point in the gumball, so I could extrude them downwards. And now what I should do is select the upper surface and the background, so I could join again the surfaces. So what do I have now? One full panel. Maybe I should add more points. Better. Great. So here you go. Now you know how to create one panel that has one attractor points that decides the radiuses of your circles. And now maybe a challenge for you guys is to discover by yourselves how you would do it for multiple panels. By that I mean, how would you create multiple panels with only one attractor point that changes them all, right? And the second thing to do is to look this up, which is attractor curves. This time, not only we're using a point, but we're using a curve that would scale down the radiuses of the circle the more we get closer to the curve. This is a challenge for you. So let's do a rewind. First step, create the surface, check its dimensions. The second step is to divide the surface by multiplying. Yeah, I guess something is wrong here. It's the U dimension. It's not even connected. Great. So now I think now it's gonna be way better. Or not. Anyways, yeah. It got some of the circles are pushing inside each other. So probably I should change the cutting threshold. Anyways, now you know. Let's get back at it. The second step is to divide the surface. The third step is to flatten whatever data comes out of the divide surface. And we're gonna use this data, which are actually the points, to first of all check what would be our maximum radius by finding the two early points, calculating their distance, dividing it by 2, and then subtracting a small amount of distance, which is going to be our CNC cutting threshold. We're going to find the radius. After we find the radius, we start creating our superstar, which is our attractor point. We reference one point, we calculate the distance between this point and all the other points, and after they're calculated, we create this little combo here to transform these distances into radiuses by deciding the domain, which is starter of 0.001, which are exactly these small points here, and a domain end, which is the biggest radius. And then we create the circle with the new radiuses, and then we grab our bounding curve, which is this one here. Yeah, and we scale it so it would leave this little offset here. Once the offset is left, we flatten again, because now we can see that the outer outcome is branch-like, as we can tell from these wires. Flatten the tree and then turn them into boundary surfaces. So what also you could see here is that I have these small red bubbles on the bottom side. So actually this is what we call a profiler. We can find it on display, canvas widgets, and we activate it. So basically this one tells us how many seconds it took for this component to create the surface. So beware when working on big projects, as you would do the same thing, because sometimes it would take hours, and then you probably need other more intermediate methods. So if you guys are interested in finding out more about how to use Grasshopper for real life design projects, talking facades, interior design, automating tasks, etc., please join our Discord down below. You would find it in the description. And also join our Patreon. And don't forget to send me a message on Instagram. I would love to know you guys better, especially those who are really willing to learn Grasshopper. Until then, see you soon.